just to allow a few more from all the representative sides to join in. We will have in excess of 183 participants, but I think we'll start at least with 50. I see we are at 46. So let's hang on for a minute, and then we'll do the official welcome from there onwards. All right. Good morning, everyone who is here. We have 54 registered online already at the moment. And I would like to introduce myself. I am Chomora Mikeka, Director of Science, Technology, and Innovation in the Ministry of Education, Malawi government. And my co-chair this morning and in this session is Dr. Verena Reisenberg, and who is just right here. I want him to greet you, and then we'll proceed with the program. This is recorded, and I'm sure that all of you have accepted the cloud recording from the host, but also that we'll be streaming this facility for continuous, access to the same. Verena, please greet everyone.
Thank you, Komora. It's of course a great pleasure for me to be able to organize and host this session with you. I must say the interest shown by the participants is very exciting. I'm looking forward to this engagement with the Malawi researchers. As Komora has indicated, my name is Werner Jansen van Rensburg, and I'm the research manager at the Center for High Performance Computing in South Africa, and I will be talking to you later on the agenda. So thanks, Komora, for the opportunity. You are now muted, Chumara. Maybe just unmute.
Thank you, co-chair. And that all those who have now joined, and thank you, co-chair, for the remarks. I would like to take you through our agenda, which most of you have already received from Verena this morning. We will definitely have, a few introductory remarks by myself as co-chair, and then I'll be inviting the Directorate or the Department of Science and Innovation, South African government, Ms. Kalabo Mlambo, but also Ms. Lindwe Gama. I have been informed that I think Kalabo is in already, and more likely also that Lindwe will be in. So I see here. So definitely they are available already to give, I would say that it's not just introductory remarks, but also perhaps to launch this virtual engagement. I would like to give Department of Science and Innovation, South African government, to do the launch of this virtual engagement. And soon after that, obviously, I'll come in and discuss some background to the National Integrated Cyber Infrastructure System, but also the facility on high performance computing. So I think I'll give some dimensions, the policy, guidelines to that effect, the agreements and provision that we have in which we are being claimed to roll out a facility of this sort, the cyber infrastructure facility. After that, I think I'll be inviting, obviously, Dr. Ivan Girotto, who is the director. You can see he's raised his hand there, from Trieste in Italy. who is the director of the master program in high performance computing. So he also gave a talk 5, close to 10 minutes there about introducing the opportunities that we have in terms of the master or postgraduate program in HPCs. And after that, we will now have the practical access examples and usage opportunities at the high performance compute, particularly from the Center for High Performance Computing in South Africa. And that will be presented by Dr. Werner Jans van Rensbeek, who is my co-chair in this session as well. So he will have quality 20 minutes time to give these practical use cases and access to the facility from today onwards, as we also contemplate to migrate from there to our own facility in Malawi, maybe by June. Now, after that, we will have 4 Malawian scientists, researchers, engineers who will make presentations regarding their work, experience, or aspiration in terms of what they can do with an HPC facility. The first one will be from the Malawi Research and Education Network, basically the CEO, Solomon Dindi, who will be talking in terms of data network simulations. So simulations is one critical thing. Then we'll have, of course, the next gen labs, which represents here private sector, industry, and the next generation innovations. And they will be presenting in terms of development of virtual reality apps, which would support education, but also industry, and also would proceed in terms of urbanization or urban planning in terms of computational fluid dynamics using CFD computations and simulations related. So those kind of practical possibilities or use cases on a facility of this sort, which could not be done on an ordinary machine. And then we'll go and proceed to have Liverpool Wellcome Trust, Malawi Liverpool Wellcome Trust, this with a research program. And I think they'll focus mostly on the disease transmission modeling using likelihood-based inference algorithms for modeling of cocoa transmission in Malawi. And after that, but not least, it will be application in agriculture, where we're looking at the detection of copy number variants, but also functional annotation of animal genomics. This is in line with what we launched, the 2 ministers of education and agriculture launched last week, the OFAB, Open Forum for Agricultural Biotechnology, and genomics or genomes was a matter of greatest interest, falling under or within the the bosom of biotechnology. And therefore, we'll see here a typical application of the same, as run on an HPC. Then we'll have an open discussion where all of us will engage each other, questions, comments, and advice and related aspects, reservations which we may have. It will be open there, and I think we'll definitely cross. The scheduled timing is 120 minutes, in other words, two hours, and we'll definitely stick to the agenda in terms of time. At this point in time, having run through the agenda and seen that we have 72 participants on the block virtually, and that this number would increase to 183, I think, in the next 30 minutes, we would like to also remind all users of the etiquette of the virtual engagement, that we keep our mics often muted. If we are not muted, we'll request our engineers on the console to mute us from a central locking position to do so, so that the recording and the proceedings are not interrupted as such. And I think now I would like to invite our Department of Science and Innovation, with whom Malawi government and South African government have the engagement in terms of MOU or agreement since 2007, to come and make their remarks, but also officially launch this undertaking. I would like to invite Kalabo, Mlambo, but also Lindwe Gama in that order. Over to you. You may wish to unmute yourself, Kalabo. I see you, and just make sure that you unmute and keep on there.
I'm not sure whether Karabo, she says she's been told that the host needs to allow to unmute. So Karabo, we will try and get that sorted soon. Benjamin is assisting. Please try.
Okay, so yeah, okay.
Okay, there we go. Thank you. Good morning, colleagues. As introduced, my name is Karabo Mlambo from the South African Department of Science and Innovation, from the Africa Bilateral Cooperations Unit. And this morning, I'd like to firstly thank you, colleagues, for the invitation. And just this morning, I will be also giving the briefing, just brief remarks on behalf of Director Ms. Lindiwe Gama, as she is not available at the moment and will be able to join us, I guess, in the next hour or so, because she did have to join another commitment. And as Prof. Mikeka has already actually mentioned, that South Africa and Malawi, under the Science and Technology Innovation, have an MOU that we have since signed in 2007. And, you know, over the years, there have been obviously, you know, a few of activities that have been implemented between institutions like the NRF, SenBio, and I am aware that Bunda College was also an implementing agency from some of the research projects between the two countries, the Academy of Science as well. And just recently, I think 2021, ASAF was also instrumental in the support and assistance of launching the Malawi Academy of Sciences. And I mean, you know, Prof. Mikeka, we are, both of us know that in the recent years, we have really been trying to, you know, revive, to make more stronger the collaboration on STI. And these efforts, you know, have unfortunately been affected by the COVID-19 pandemic. Though one of the efforts as well was actually a visit to South Africa from our Malawian institutions, you know, for facilitated visits to different institutions, which, you know, the hope was for final discussions to go towards the joint plan of action that we will therefore also implement on various thematic areas. You know, so I think in today's launch of this very, very successful user engagement under the CHPC, it is great, you know, to find out that the work will be implemented on the ground. So even in the midst of a global pandemic, our economic, social, and political activities coming back to normal will allow us to, you know, implement these very good and successful activities. So I'd obviously like to express my enthusiasm for the work done by the CHPC together with the Malawian Ministry of Education, the universities and research institutions, which means great success towards the implementation of our bilateral partnership. And most importantly, the achievement of the SADC cyber infrastructure framework, which has great work, firstly, which will benefit, obviously, both countries' research institutions, research communities, the national system of innovation, and obviously, you know, the work needing to go down to, you know, for our citizens, you know, to know the work that has been done in our research and infrastructure environments. And obviously, secondly, the need to enrich and develop the larger region of SADC. South Africa itself is on a growth trajectory to improve the innovation system and create a solid and conducive environment for all role players, stakeholders, and beneficiaries. It is only befitting that the DSI extend support as well to Malawi to achieve increased research innovation outcomes or results for development. Furthermore, to HPC activities, there is a great opportunity for South Africa and Malawi to closely collaborate on public funded initiatives that pilot innovative technologies, as well as collaborative technology demonstration projects in various strategic thematic areas, which will in fact include partnerships with private companies as transferers of technical, professional, and specialized skills and services. Prof. Migeka, with those few words, I would like to thank you, and once again, thank you for the invitation and wishing you all a great event. Thank you, Prof. Over to you.
And you can officially declare the virtual engagement opened. Would you like to do that from the Department of Sciences? Yeah.
And as a representation, I would like to formally open the launch of this event. Thank you.
Thank you, South African government and the African bilateral senior officials, Kalabo Mlambo, but also Lindwe Gama. Before I proceed, I see a hand up from Humphrey Chiputula. Do you have any interruption or interception? Humphrey Chiputula, your hand is up.
Sorry, Prof. That's he just has audio problems. That's all.
Okay. All right. All right. So the host is the engineers are assuring us of that. So let me recognize from the Malawi government seated here also virtually. The senior government officials. We have the director of higher education, DHE, Dr. Levis Enea. May you just say hi? Yes, that's Dr. Levis Enea. You can say a word. Yeah. So okay. So that's a wave, and then secondly, I would like to acknowledge also the Deputy Director, Information Communications Technology ICT, Chris Mtonga. I think she can also wave. There she is. Just to show the commitment. Yes, thank you. We see you, Chris. The commitment that the government has and Ministry of Education in terms of the undertaking that we're taking off from today. I see also here across the whole spectrum, Malawian researchers from universities, public universities, private universities, secondary school, science, technology, or STEM, facilitators and teachers are here. Engineers are here. So it is indeed the whole framework. We wouldn't have managed to do a single individual introductions, but you can do so by just texting, if you so wish, on the chat, because all this will be actually recorded. So you can do that in the chat, definitely. So that, but the good thing also that you were registered, what we are missing in there, apart from the name, email address, is maybe to know the institution, apart from inferring that from the email address, your institution and your research area. I think that information might be very critical to be done for full profiling of who is here. So maybe you do that on the chat. And I would like to proceed with giving a background. I see the chat is working now. That's pretty cool, and that will be saved appropriately. I also want to be assured I'm seeing all the speakers that we had dated. They are here and they're getting ready. It's good. I would like to entice and excite those who are here how this idea of HPC in Malawi came about. I would say that Malawi has been, most of us who are here have seen the evolution of computing power, hardware and software in Malawi over decades. I, for one, I can say, like, from 1980, I was 2 years old. We have seen the first computer having a single processor, the 8080 processor, being of great interest. And then from there, the 1985, 885 processor, we've worked with that. And when I was finishing my engineering degree, in 2002, that's electrical engineering. I did my thesis or my dissertation on a computer. I mean, I typed my work and was able to save my thesis in a 1.44 or 1.44 megabytes MB floppy disk, and I can't imagine how it was able to fit in there. It had drawings, being an engineering program. I don't know how I managed to have images less than 1 MB. I don't know what happened. There were not digital cameras and stuff like that. And since then, we have seen Windows evolve, starting from 3.0. I think some of those who are joined here, they've done DOS-operated Windows, and some of them, they have worked on Windows without all the peripherals on there. They have used the keyboard to be the mouse, to be everything else. And in DOS, the DOS commands have run them and made them stars. We have seen evolution of internet connectivity since 1997 using the UNIMA electronic network. And we have seen usage of different operating systems. Linux became popular since 1997, Linux and Unix, because we were saying, how can we now accommodate large data, on a Windows machine, on a processor which was a bit slower. And then Unix solved that. And we had to migrate from Windows or DOS to Unix. And we were able to do a lot of more things, including the networking aspects. And we felt that we had an answer there, and we have seen an evolution of various flavors of Linux, from Slackware, Mandrive, Unix, and all that. And Windows also did the same. And the computers were becoming small, from large to small, from where we had discussed of super booth computers or clusters. Yes, we heard about those ones. We heard about large storage capability, but it was very expensive. We heard and read about high processing power, but it was not attainable in Malawi, most of the African countries. Some of us, we got these opportunities from ICTP, the International Center for Theoretical Physics. And that's why you see here, Ivan Giroto is here since our cooperation, since 2003. To make ends meet, to be able to simulate, to research, and all those kind of things. We have studied in various programs. Most of you have been in all the countries in the world. You have used different facilities. You come home, you fail to research because of those kind of limitation, computational power, load, but also processing power. And apart from that, we have also had a demand recently when Internet of Things has come, data science, big data, and all this, to be able to simulate, to handle big data, to do analytics of the same on a very small, tiny devices, like the IoT devices. And in that case, the optimization of computational power, but also processing and including data, storage, has been an issue. And some have taken PhDs around these themes in Africa and beyond. And still more, we see that certain computations are required to be done on the edge, and certain computations are supposed to be done in the cloud. And that's why we have seen a lot of master PhD programs in cloud computing and all those related aspects trying to solve the same, and cloud as a service. And that's why we see now we are happy whatsoever is happening, the recording is happening on the on a cluster, but also in the cloud. And therefore, all these cannot be solved without a policy environment, without agreements, without collaborations, without partnerships, without putting these things in the national blueprints. And so therefore, what I would like to expose to you is the framework in which we are operating. How did we now say that I think we are ready to take off? We have the framework, the policies, the strategies, and we need implementers themselves to sit and come forward to see how we can have our own national integrated cyber infrastructure system, but also high performance computing from a date like today, 7th April, going onwards. So therefore, my presentation in the next 10 minutes, 10, 11 minutes, will be centered on 3 aspects. Number 1, the agenda of the ministers last year. What did they agree? What were they invited to approve? I will highlight that one. And secondly will be the MOU, the Memorandum of Understanding or the agreement between the Department of Science and Innovation, but also the Directorate of Science, Technology and Innovation within Malawi and the National Commission for Science and Technology, NCST, particularly paying attention to the draft joint plan of action so that we begin to implement the agreement. The last one, which I will present, is the National Development Agenda, the Malawi 2063 and Malawi Implementation Plan 1. On specific pages, what are the provisions in terms of strategy and the priority interventions, which point us that today, if we cannot take off in terms of HPC, then it will take 10 more years to recover from the loss we would have lost from today. And I'm happy that I think today we have joined in numbers. So what I'll do is I'll highlight a few aspects on my screen. I'll start with the this slide. Not slide per se, it's a documentation. In this one, I would like to mention that in 2016, ministers in Botswana, ministers of education and technology, science, technology and innovation, they approved that there be a cyber infrastructure framework. But from 2016 to 2018, nothing happened because there was no implementation plan. And therefore, in 2018 in South Africa, an implementation plan was presented to the ministers in terms of the cyber infrastructure implementation strategy, and it was approved. And then in 2019 to 2020, there were activities indeed which showed the progress in terms of the rollout of cyber infrastructure systems, the support which came through from the Center for High Performance Computing, where Vaccination is coming from, and others, but also the Department of Science and Innovation in terms of funding, and also from the SADC Secretariat. These kind of interventions made a possibility that several African countries, for example, Namibia, were able to simulate and roll out programs in solar materials, which is material science. Botswana and Mauritius were able to do several programs in terms of chemistry, computational aspects in chemistry, physics, and mechanics, and the data science. In terms of COVID-19 vision, it was done there from Angola, from a high performance computing facility. Sieve methods in computational mathematics was also being done, but also astrophysics. And therefore, ministers were invited in June, on 15th June 2021 last year, to note the progress in terms of these activities since 2019 and 2020 in the areas which have been mentioned in there, and that the cyber infrastructure rollout and the policy exchanges be approved, and they did. So in June, ministers of education, training, science, technology, and approved the rollout to be expanded to more African, SADC member states, the 16 of them. And this is the point at which Malawi made a pledge. As a chair of SADC this year, we said we must also have it rolled out within the provisions, because we see it already, included in some of our national development agenda, which we have. The collaboration, I just want to highlight that this was going to be a matter that ministers were invited to commend South Africa through the Department of Science and Innovation. That's why we have Kalabo Mlambo here, and the Center for High Performance Computing for providing the necessary technical. So we have Verena and team here providing the necessary technical and financial support in developing cyber infrastructure capacities and infrastructure in the region over the past years. And therefore, from this, we say, no, Malawi, I think with the cooperation that we have, we should be able also to move immediately in terms of receiving, making a bid for the infrastructure. And if we qualify, we receive such infrastructure donation at a site of interest, and therefore issues of site definition, within the public research institutions or universities, private centers of specialization and centers of excellence was considered. Deployment of the same to be done after the site is known, which is in the process, but also user definitions. And we are here as users, potential users. I will see how we can immediately be engaged from today onwards and later on to be migrated to our own infrastructure, where we would have the ministers coming in 14th to 17th this year in Malawi as chair of this, to have a privilege to visit such a site of deployment. And of course, the governance aspect of such kind of a facility. So this is from a SADC perspective. However, beyond that, I would like also to highlight, I'll stop sharing this one, and I'll share what we have as a draft plan of action. If you look at the draft plan of action that we have had between the Department of Science and Innovation, you will see that we have agreed to have a joint research program, and that's why Kalabo Mlambo was mentioning about the Wana or Bunda College in terms of the Sanbao with National Commission for Science and Technology, but also related research in terms of those areas. The other aspect is joint funding, modalities, but also institutional human capacity development. Human capacity development is enabler number 5 of Malawi Implementation Plan 1, which in there, it mentions the 2 critical aspects: access to research institutions using ICT, but also there is a mention there of high performance computing facility or capacity infrastructure. So we are tapping from such, and we are highlighting the need that through our cooperation, we should be able to roll out such. In terms of okay, I hope I'm still there. In terms of the agreement that we have with South African government, one aspect which is clearly mentioned in there, it's the aspect of equipment and apparatus sharing. And in there, we have specifically, mentioned of the need to share equipment of research of the caliber that we're talking about. And this is also provided for in Article 6 of the agreement, which was established or signed in Lilongwe on 13th August 2007. Regarding the third aspect, which is Malawi 2063, and I wanted to specifically share this kind of provision. In terms of Malawi 2063, we have I think I should be able to share from here. Yeah, so from the Malawi 2063, you will see that on that specific page, we have put a strategy to expand educational infrastructure, which includes science, technology, and innovation to accommodate learners at all levels. This is from ECDE, primary, basic, secondary, and higher education institutions. That's why the director of higher education institutions is here. And particularly when we do so, we have 2 critical strategies. One is to establish an online education big data center. We cannot mention of a big data center without having a national data center, or without having national integrated cyber infrastructure systems, or without having at least a cluster in terms of high performance computing, where we have storage, but also a capacity to do activity number 2 or prioritized intervention number 2, which is expand virtual science laboratories for science, technology, engineering, and mathematics, simulations, and analytical sciences. So we expect that from a facility of this sort, and these are the kind of bid that we made to SADC and its partners, that with this kind of facility, education, academia, and research will be able to run simulations, but the private sector also can do the same in terms of research and development, which is going to be critical in terms of making sure that we align and address the issues in the 3 pillars that we have in Malawi 2063. industrialization, agricultural productivity, but also urbanization. So that's why one of the presenters will be presenting in terms of urbanization. What solutions can run on HPC to solve urbanization designs, but also specific problems. So I think these are the kind of aspects that I wanted to highlight. If you go, we check on this particular document, we will see that the human capital enabler, if I just go to page 78 of this and say that, you see that this is a...
Komora, can I maybe just interrupt quickly? You may be showing the wrong page. We're not seeing the document at the moment. We are seeing the Creator Studio window, so maybe you can just check.
Okay, all right, okay.
On the sharing.
Okay, so I think I may have... how about that now? Are you able to see...
seeing the picture? Yes,
you see the picture.
Good.
Yeah.
Yes.
Yeah. So this is enabler number 5, which is human capital development, particularly within the Malawi National Development Agenda, MIP1. You see that this is a desire that whatsoever we want to do must have computational power, and that's why we have it in there. And this computational power is being summarized on this page. I think now we are able to see. Are you able to see this page? Can I just confirm?
Yes. Yes, it's clear.
Yes. Yeah. So now you will see that here we are talking about the establishing of online big data center, but also expanding virtual science laboratories for science, technology, and engineering, mathematics, simulations, and analytical sciences. And this includes also under the pillar of industrialization. In this same document, which is a government policy document, under industrialization, we're talking of research, science, technology, and innovation, and the computational aspects are high on demand. I wanted to summarize these, that I think these are the critical aspects which are motivating us as government to ensure that we are able to promote the development of what we are doing in terms of development of the national integrated cyber infrastructure system, but also the high performance computing facility. Considering where we're coming from, the 8080 microprocessor, to the single board computers, which have limited computational power right now, but also to the expanded portfolio that we're looking forward to. And based on this, I would like to invite Dr. Ivan Giroto. But most often the time when we do this, we really also want to make sure that those who are researching, for them to have maximum utilization on the facility, sometimes, mastering in that requires, could you give Ivan an opportunity to share the screen? I think I see a text in there. Yeah, to have share screen rights. So we need to have an opportunity to understand what other postgraduate programs are there to run, apart from the trainings, which we will definitely be able to provide. I think now I give it over to Dr. Ivan Giroto from the International Center for Theoretical Physics, ICTP, Trieste, Italy, to give a few slides around this. And then we'll proceed with Verena in terms of practical access to the facility. Over to you, Dr.
Yes, thank you very much, Professor Mikeka. Thank you very much for the opportunity. I would like to thank also Dr. Van Rosenburg for the opportunity. So, yes, I mean, I am Ivan Girotto from the International Center of Theoretical Physics in Trieste. And actually, I think, I mean, this fits quite well with the event of today, in a sense that basically 8 years ago here in the area of Trieste, together with CISA, which is the one of the more relevant center in Italy for research, a world-class center for research in theoretical physics, and one of the most relevant schools for PhD in math and physics in Europe. So, which is basically few hundred meters from the International Center for Theoretical Physics here in Trieste. Together with them, we joined in a program exactly to try to answer this question. So, how do we close the gap between the available computational resources and the requirement of demand for scientific simulation and scientific research in computational science. So we started with a program with very few key aspects. So we have developed this is, I would call it a professional master, in a sense that is a post-graduated master, intended to really form professional level skill set in what are going to be the leading key players in research and industry in the area of HPC in the next years. So we put together with CIS and we developed a program that I'm going to introduce now briefly. So we had the 8th edition at the moment. We host about 10-15 students per year because of the really high and frequent interaction that we want to have with students and to try to form and educate them in the best way possible. Consider that this program is basically a job, it's 8 hours a day every day for about 1.5 years. And so there is a very close exchange between user and staff that results in the number that I'm demonstrating. So we had about 100 students, 120 now students during the year, out of which 20% a woman, but with a very good achievement of about 95% of the alumni that are now employed in academia or industry in world-class center from Cambridge, Stanford, Max Planck, Barcelona Supercomputing Center, Cineca, and other ECTP, CISA, and other world-class research centers. So the program is divided in 3 main pillars. It's 6 months of very deep introduction to technology, from let's say software environment to hardware, and up to an extreme course that we have on high performance technology, where basically students stays for 2 weeks in a lab trying to build cluster from scratch and try to be able to configure and make them available to researchers. And then we have a second part of 3 months where students are exposed to main computational problems that are common to modern scientific application. And then we have a 6-month project, 6 to 9 month project, which is normally in collaboration between research groups here at the ICTP or CISA or with industrial partners. So here is a portfolio of partnership that the master has been achieving during the years. Sponsorship, collaboration that are mentioned here are in terms of either sponsorship or collaboration for thesis project or collaboration for lecturing, because, for example, we have Intel, which comes to do advanced courses of software optimization. We have people from ICL US come to describe my library for linear algebra and so on. The master is founded on scholarship. There are scholarships that are achieved through the TIP for HPC fellowship, so through a CISA partnership with the business partners in the region in Italy, but also across Europe. And then there is the ICTP model. So ICTP every year sponsor about 30% of the scholarship. So 4 or 5 students every year are fully sponsored from ICTP, meaning that they are supported a return trip from the origin country and the basic salary to survive in Trieste for the time of 18 months. Of course, as ICTP, we are really much interested to extend the scholarship portfolio. Consider that normally we receive about between 200 and 300 applications per year, and we are only able to support between 4 or 5 students. So we're trying to extend this portfolio of scholarship, and ICTP is in the process of creating indeed a consortium for computational science, which is going to be a container of all ICTP collaboration that are in the direction of computational science, from HPC to artificial intelligence, machine learning, and quantum computing. And therefore, very interested in seeing initiatives like the one you are proposing today of collaboration between Malawi government and the South African government through the Center of High Performance Computing in South Africa. Thank you very much for your time. If you have any further question, I'm available via email. You can reach me through the Master HPC website, which I'm showing here, or through the mailing list that are mentioned in these slides or in the ICTP website where you find all the references. Thank you very much.
Thank you very much, Dr. Ivan Giroto, exposing various opportunities. I see Arnold Valalo, your hand is up. Is it intentional or accidental? Arnold Valalo. All right. I would like to thank Ivan, and that definitely you have some comments or questions during the open discussion moment. So sure. Stay there, and definitely you have engagement, and also so that we also begin also to crystallize the collaboration in terms of the computational forum, the coordination to benefit maximally as Malawi or the region from the provision that you have in there. Once again, without much ado, I'll be inviting Dr. Wegner Jans Renzebek, my co-chair. You can give your remark as your co-chair, but also definitely take up the 20-minute presentation in terms of the practical access to the facility from Center for High Performance Computing, Chpc, South Africa. Over to you.
Thank you very much, Chumora. I'm sharing my screen, so maybe you can just confirm whether you can see the full screen there. Is it looking good?
Yeah, yes, I can confirm we see the cheetah. Is it a cheetah or leopard? Whichever way.
Most definitely a cheetah, so don't confuse it with a leopard, and I will talk about this cheetah a bit more. Thanks for the opportunity, and thanks to you and Dr. Giroto and Karabo and so for setting the scene. I think it is clear that this is a very well-established collaboration within the SADC framework between South Africa and Malawi, and the CHPC is just so pleased to be part of this and to be playing our part in promoting the Hpc initiative. So I will focus in my talk very much on the practical aspects of how we see the CHPC to be involved in this partnership. That's why my talk is very much focused on the Center for High Performance Computing, which is the national supercomputing facility hosted in South Africa. So yeah, I will focus on some background examples, usage opportunities, practical access. All of these things are immediately available to Malawi researchers. But maybe just one step back and just say, well, the main aims of this researchers' engagement, I mean, I'm not dealing with all of them. The first one is mostly been dealt already by Professor Mkeka and the background that's been provided. All I want to say is that when it comes to the initiatives of HPC infrastructure and services provisioning in Malawi, this is a key project where the CHPC is provisioning and assisting the provisioning of HPC resources in Malawi. We will soon start with shipment of one rack to a site to be designated in Malawi. So it's very practical. There's going to be a system on site for researchers and for system administrators to be trained. And this is all done through the so-called Hpc Ecosystems Project that the CHPC has been launching for a number of years already, where we do the commissioning and provisioning of HPC infrastructure to other local sites in South Africa, but also to SADC countries and SKA partner countries. I'm not going to say much about it. I think this is one part of the project. The part that I'm going to focus on is the second bullet, and about communication of the immediate opportunities for Malawi researchers to access and use HPC resources already that is being hosted in South Africa. So there's a distinction to be made. The researchers in Malawi can access South African resources, but also the moment that the resources are provisioned and commissioned in Malawi, you will also be able to access it from there. But you don't have to wait because it is not quite ready yet, and there's still some shipments and implementation that needs to happen in Malawi, but you can start with immediate access in South Africa. And I will talk more about this. And of course, the third bullet is to me almost the most important, is for me and the CHPC and colleagues to gain. And I can just say I've got a number of CHPC colleagues on the line as well that is listening to these talks and to get understanding of what the needs for Malawi is, but to understand the Malawi researcher needs specifically when it is to do with HPC and access to HPC for modeling and simulation purposes. So that is why I'm looking forward to the presentations that will follow mine. I have I've probably too many slides, and I also have some hidden slides. I will share this after the talk. So I will maybe jump over a few slides quite quickly, but don't worry, we will get the slides. There's unfortunately not enough time to give justice to all the things that I suppose that we can talk about. So apologies for going a bit fast. But maybe just some introduction to the Center for High Performance Computing. It is a national high performance computing facility or a supercomputer facility in South Africa that is directly funded by the South African government through the Department of Science and Innovation, the DSI. So I'm very pleased, Karabo, to have you on the line as well, to be able to demonstrate what the initiatives of DSI are and how it is being implemented in South Africa. This is actually being done through the National Integrated Cyber Infrastructure System in South Africa. This is called NICIS, which in turn is then administered by the Council for Scientific and Industrial Research, the CSIR. So the CSIR, of course, is similar to a national lab in the country. So the CHPC already started operations in June 2007. So we are going for about 15 years now already, and it is based in Cape Town. And until recently, it hosted the largest HPC system or supercomputer on the African continent, where it is dedicated to research purposes. The CHPC has a total number of about 35 employees, which is contained in 3 divisions: the research division, which I'm heading, but we also have a technical division and an operational division that makes sure that the services and the infrastructure that we offer is always well maintained and available for use. So maybe just to put us on the map, in South Africa, and in fact in Cape Town, it is where the facility is hosted, and there's just a picture of the front of the building. We always like to emphasize the beautiful part of the world that we are hosted, but also to emphasize that although we might be located on the southwestern tip of Africa, this facility is very much accessible to everybody, no matter where you are, because all users access this online. So I probably don't have to tell this audience, but of course, high performance computing, the applications of this is diverse. So whether you are studying the drug discoveries or maybe the airflow over a car in, say, a computational fluid dynamic simulation, or something simple like the design of a Pringle chip, all of this can be brought back to high performance computing. And I encourage you, go and look at this article if you don't believe me. This is indeed a practical application. But I will come back to some of these applications soon. Maybe just a step back. When it comes to what the South African Department of Science and Innovation is funded, it is the National Integrated Cyber Infrastructure System. And I like to refer to this as the Cyber Infrastructure Triangle, of which the computing services component is what the Center for High Performance Computing is. But very importantly, there's also a networking services, the South African National Research Network, and also a data services or data and archiving storage services, which is the Data Intensive Research Initiative of South Africa, the RISA. And you will see that these are 3 important legs in the cyber infrastructure triangle that is funded by the South African DSI. And very important, all 3 needs to be supported. Otherwise, you cannot offer a proper cyber infrastructure service offering. For example, if you only had a computer, but nobody can access it properly, you cannot manage your data, it will not have much use. And I think the DSI in South Africa is to be complimented for the vision to fund it in this way for many years already, and to assist in helping that the cyber infrastructure services is well embedded now for the users. And of course, I emphasize again, this is also for the benefit of Malawi researchers. So just coming back to the CHPC, the Hpc cluster that we have installed there is getting a little bit old now. The second phase, and what we currently still have, was already implemented in 2017. It is a 1 petaflop system, and at the time of launch, it reached number 121 on the top 500 list of supercomputers in the world. I think it's important to note that this was the only system from Africa on the list at that stage. So it just showed the state-of-the-art facility that we had on offer in South Africa, but of course also for our South African partner countries. All of these systems, it's tradition to give it a name, and it is named the Lenghau Cluster. And Lenghau is the Setswana word for cheetah. And it's very appropriate for us to call it cheetah. It's very African and South African. And yeah, we don't only want to think about this as fast, but we would like to think about this as the fastest. And that is why the name, I think, is quite appropriate. So every time you see the cheetah, hopefully it will remind you of the South African supercomputing facility that we have on offer. Maybe just in short, some details. This system has almost 33,000 cores. contained in 1,368 nodes. It has an interconnect InfiniBand 56 gigabits per second, which ensures that there's fast and low latency connectivity between nodes for launching of parallel computing jobs. And then also we have a 4 petabyte storage facility hosted together with the compute. This is our scratch storage where data is kept for short periods to be able to launch and write data during simulations. So yeah, you can have in your own time have a bit more look at the details of the system. We also have a GPU cluster containing 30 NVIDIA V100 nodes, the graphics processing unit cluster, which we launched already in 2018, which is heavily utilized. It's actually a bit overcapacitated at the moment, and we are thinking, of course, on ways on how to expand this. Mostly used in the chemistry area for drug discovery, docking of molecules or proteins and molecular dynamics simulations, but the other 50% of this used for machine learning and AI type applications, which is, of course, a very efficient way of doing this on the GPU resource. So this is also available for all users of the facilities at the CHPC. And most recently, in March 2020, we started to launch the Nikki's production cloud, which is named Sabawa. So this is still a modest offering, but it is growing significantly with more resources on site already to expand this. And this is in recognition of the fact that users need environments that they can set up and use more for their specific needs. So this OpenStack CentOS-based system is available on application for users. Also, if cloud provisioning or cloud needs is what you need to have addressed. So this is just a very brief summary of the resources. What is the mandate of the CHPC? I always put this bullet first. We are a research enabler via HPC. It means that we are not doing research ourselves. We are there to help others to do research, where modeling and simulation, especially through the access to high performance computing, is what you need. And we do this to many different classes of users. Of course, the South African academic research community is first, but most definitely also the African SKA, the Square Kilometer Array partner countries, and SADC partner countries, of which Malawi is part, is part of the users that can access the system. We also have a non-academic public user base in South Africa, as well as a small section of private sector users in South Africa. And I can just emphasize that for all the public and academic sector users, access to the facility is for free. You don't have to pay for this access to the hours, but for the private sector in South Africa, there is a cost recovery fee to use. Now, this research enabling role of the CHPC is fourfold. Of course, firstly, access to the HPC hardware infrastructure, but also for code and software support. We make sure that researchers are supported and they need codes to be compiled and made ready to use on our systems. We also have a group of research and real scientists and engineers that support specific domains. So if you need support in your domain area, we are most likely be able to support you. And then training and education initiatives or human capital development is a core part of the mandate that we have. So all aspects of training HPC related, we have a focus to deliver. So in terms of resources, the people I already mentioned, domain-specific scientists, engineers. I list the domains where we have at least one person full-time at the CHPC. These are the main, say, areas that research is being done. But if your domain is not listed there, it does not mean we cannot support you. We successfully succeed in supporting all domains, because when it comes to, say, compiling and making codes available for use, these people are skilled enough to make sure it will work for you. We also have a dedicated technical support team that makes sure our cluster and systems are maintained on a regular basis. And we also have an advanced computer engineering laboratory, which we call the ACE Lab. In this laboratory, next generation architectures are being tested. And this is a part where we do our own HPC research, very much focused on hardware and software components for advisory purposes to the CHPC, but most definitely also to entities external to the CHPC. A lot of focus in this lab is also on the more recent developments of cloud provisioning, and also more specifically how you're going to do HPC provisioning in future through cloud. So there most definitely people can benefit from the knowledge and skills situated in this lab. And then we have trainers. Now, we don't have any full-time trainers at the CHPC. The trainers comes from all of the above. So all the people in this part of the work also do training as part of their work. Okay. Now, just some specific numbers on the CHPC usage. Now, I like to always talk about all time, and then maybe more recent in the last 6 months that I checked these numbers just 2 weeks or so ago, on the 23rd of March. But all time, it is since April 2016 when Lenghau was launched. We had 467 active research programs. So define active as there must be at least 1,000 compute hours used. Now, these research programs are typically when a professor, say at the faculty, has a research group of postgraduate students, they register a program at the CHPC, an allocation of hours are made for a certain period, and those hours are then used for their research projects. The total number of active users all time, and also the total number of hours, compute hours being used, is just over 1 billion hours. And you can now look at the last 6 months, it's 41 active programs, the total number of users and the total number of hours, 75 million core hours have been used. It gives you a bit of a snapshot of what the current activity on the Lenghau compute cluster is at the CHPC. But again, I want to emphasize it, the usage. And if you look at this past 6 months, the 75 million hours that's been used, 81% of these hours have been used by South African universities. I think it makes sense. This is where the core of research is being done in South Africa. And you expect a national compute facility in South Africa to cater mostly to the needs of that community. But importantly, there's also the 4% of this to the South African public sector that makes use of this facility. And then a growing sector of SCA and SADC partner countries, about 14% of the hours have been used. Of course, none of this yet by Malawi, but Malawi is free and to start using this as well. And then we have a even smaller South African industry or private sector component of users that's using about 1% of this resources. So I trust it gives you a good indication. And maybe just one last pie chart on the kind of domain areas where these hours are being used. And you will see the biggest ones, material science is quite significant, 28%, chemistry about 23%, other one, bioinformatics, 25% are the big areas where lots of users are using. But other domains are also well represented: computer science, earth science, the climate modeling, health science, mechanical engineering applications, physics, astronomy. So I trust you will agree that in terms of the mandate of the center to provide resources for diverse and all research domain areas, that we are succeeding in doing this if you just look at the distribution of numbers of hours being used. So in terms of practical examples, I'm not going to waste too much time here, although it's very interesting, but I see my time is running out. I just want to highlight some areas. I mean, in terms of material science, chemistry, health, there are many different research programs. I'm just giving some representative images here of work that's, say, doing the drug discovery or the catalysis or the material science for battery development. So on all of these programs, more details can be provided if needed. Also on the astronomy side, through our interactions with the SKA program, astronomy research, space science research is some of the key areas. I think engineering always is some of the most interesting examples to show whether it is the design of buildings in terms of wind and other components, even high-speed trains, computational fluid dynamics type applications, even the design electromagnetically of the dishes for the SKA project. All these things have been done in research programs at the CHPC. I always like this example where we did some consulting work through my colleague, Dr. Charles Crosby, where a design of a building near Port Elizabeth in South Africa in the Eastern Cape, which is a very windy area. And the Port of Nkura wanted to design their new head office. And they said, well, please, we need to design this building so that, well, the forces of the winds are mitigated, but also things like buildup of sand onto doors and so on can be managed. And this was a project that was done at the CHPC, and it helped the architects immensely to design this building. And I think the satisfying thing about this is that this building was built and that the recommendations that came from CHPC played a key part in this. And I think it's closing this loop on practical projects that is the beauty of HPC applications. But there's many other examples. For example, arc, electric smelting, modeling the flames of smelting. And these are very difficult things to monitor experimentally, but if you can simulate it well, you can gain a lot of interaction. So this is a quick case study. Something else about diamond mining on the west coast of South Africa and Namibia, very specialized components that you need to extract the diamonds harvested from the sea floor. So we had a long-term collaboration with De Beers Marine, that is the private sector entity that does this. Other areas like climate modeling or earth science applications, very strong research group from the CSIR, focusing specifically on the Southern Hemisphere, whereas most of this research is coming from Northern Hemisphere research groups. So important contributions made to IPCC reports for climate modeling from this work. And these are some of the biggest users on the CHPC, where some big simulations are needed to run. And maybe just the last one, collaboration of South African weather services, where the CHPC acts as a failover facility. So if say they cannot do their short-term forecasting on their own systems, we are ready to help them. But all their research is being done at the CHPC. They simply do not have their own capacity to do their research. So hopefully these examples give you some indication of the areas that we are assisting, but it's by no means a complete list. I just wanted to whet the appetite a bit, and we can certainly discuss more of this in detail. Just a slide on training and developments. We have dedicated the CHPC training events. We have 2 annual events, what we call the introductory programming or coding school, that focus on introductory aspects of Linux and Python training to assist users that needs to start using our systems every year, running in February, end of January, February. We also have the winter school in high performance computing, which is the next level of training, usually running in July, August. And this is virtually being done over the last 2 years due to COVID, but we are ready to also accept participants from other places. And then other areas is student cluster competition. This is undergraduate training initiatives or opportunities for students to participate in learning about HPC. The Hpc Ecosystems Project is the project that provisions hardware to other sites and countries. So we will be working closely through this project with Malawi, and then many other domain-specific workshops and ad hoc, depending on what users want. I want to highlight that we have a CHPC National Conference every year, the first week of December, that I encourage everybody to attend. It was done virtually for the last 2 years, and maybe there will be some on-site this year. Chances are very good. So we would look forward to welcoming people to this conference if you want to learn more about CHPC and all its collaborations. And then some other training events there as well. And then a last slide, and I want to emphasize this point to Malawi researchers. Practical access to the CHPC is available. So this is very much the quick summary slide. It tells you what we mean, what is a research program, how do you apply as a PI. This is can only be done by, say, faculty members at academic institutions, those ones that are leading research groups. If you're just a student, you register as a user and not as a PI. So a PI registers, you get a research program, hours are allocated, and the PI then add members to that program and then manage the usage of that program themselves. So the registration procedures, this is the most important site. This is the user portal at the CHPC. All the information is summarized there. If you follow this link, users.chpc.ac.za, you get all the information I'm talking about now. It tells you the distinction between principal, investigator versus user, how allocations work, scheduling, how do you submit jobs to queues, how is it being managed to be fed to the large user base of the CHPC to ensure that one user does not use all the resources, the limits that you have there. Also, how do we manage our storage, our Luster, scratch storage. This is a very important part of the services being offered. You need to get your data there and to launch your calculations from some place where it is fast, accessible, and stored. How we evaluate these educations, this happens all online, how we support through help desk. So I don't have time to talk much more about this, but these slides will be available. And in the next few slides, you will see all of this is discussed in a bit more detail. The research program educations, how you can use the CHPC on-site wiki as your first place to look for practical information with the site there, really practical, tells you step by step how to do certain things that you may not know how to do. Our CHPC help desk, this is the key place where we support our users. You log a query, and I'm very proud of this help desk. It is very effective. If you have, as a user, submit a query, you will be helped almost immediately. This is the way that we do it. We track all the queries and we attend to what you need help with. Yeah, so this is it, Chomora. I have take-home message. I hope that all these take-home messages came across in my talk. The CHPC has a long track record of HPC service provisioning, state-of-the-art infrastructure, skilled employees to assist Malawi researchers where needed, training and human capital development, a key part of what we do. The CHPC Ecosystems Project will be key in assisting with the infrastructure provisioning in Malawi. Immediate access to CHPC Malawi researchers. You can start with the site given the user portal that gives you practical access and registration procedures. And yes, we are very keen for productive collaboration with Malawi. And I think this engagement session is a very good start. So sorry for going over the time a bit more, but I hope I could get the message across. And if not now, there certainly will be time a little bit later on for more questions. I will work along in getting a link to these slides ready and put it into the chat straight away so that people can go and have a look. Thanks, Chamora, over to you.
Thank you very much, Werner, for such elaborate presentation. We appreciate, and the invitation that immediately the 91 who are available here can indeed log into the portal and register to begin to do what is possible to do on the CHPC. So that invitation is open from today onwards. It's within the provisions of decision number 12, which the ministers made out of the 22 decisions of the SADC, that we should be able to exploit the CHPC as also we migrate and establish our own eventually with the trainings that we get on there. On the CHPC, the PhD doctoral candidates through their PIs or supervisor, they should be able to publish a lot from most of the simulation that they're able to do. And that's one thing that we want to see happening, coming up with the new designs in all those specific areas. Understanding the fact that as the graph which Werner showed, where 81% of the South African investors are occupying the space and facility, we got an insight that in Malawi, we need to come up with a technical team since December, and we had engaged all the vice chancellors who provided 2 technical people from each university, public investors in this case, 12 of them. But also understanding the triangle which he showed in terms of the SANRAIN, the South African National Research and Education Network, the computational aspect and the data aspect. We also engage the Malawi Research and Education Network, MARIN. So this is why we have this consortium. We have 13 technical experts in Malawi, and this is just a starting number. It will be growing. We are open, and these are the ones who are, contributing towards the whole process in terms of issues of site deployment, user, and then eventually we'll be going to governance aspects. I think I appreciate that, and some of the things that you have touched on will be, I'm sure that also will be replicated by the presentation that we have going forward. From Malawi, we need to know, is this an issue in Malawi? Is it of interest? Are we able to jumpstart ourselves immediately? And I think I'm expectant to listen to the 4 experts. The first one here being CEO for MARIN, Malawi Research and Education Network, Solomon Dindi, who has no more than 10 minutes to present their work on data network simulation. What has been the issue? Are you there, Solomon Dindi? Would like to give you the floor. You are recognized and your slides are open. Over to you, Solomon Dindi.
Thanks, Prof. Thanks, everyone. Thanks to previous presenters. My first statement is in 2004, sitting in a classroom in a lab at the University of Malawi under the guide of Professor Mikeka, I did a bit about Z80 processor. At that point, the university had a bandwidth of only 64 kilobits per second. Quite bad at that point. Today, the bandwidth has increased by about 5,000 times. A big increase, but not much. We still need to do more. I go straight to my presentation. Okay. I think it's a given point that higher education and research.
You might want to put it in the slide
presentation mode. Thank you. So it's a given fact that higher education and research remain the key drivers of the knowledge society. But in order for those institutions to achieve what they're supposed to do, there is need for them to be able to access information and extremely large data sets, and that must happen with a lot of ease. And in order for this to happen, we need these institutions to have reliable and high capacity connections, as well as issues of high computing capacities. In particular, we are looking at issues of RAM, CPU, and hard disk. Of course, universities realize this together with research institutions, and generally across the globe, they have come up with associations which we technically call national research and education networks at national level. I think I give examples there, Marin being one of them in Malawi, Zamren in Zambia. I'm happy that the co-chair already talked about Sanren as one of the national research and education networks, driving the agenda of higher education and research. And of course, at regional level, we have what are called regional research and education networks. Our example in this region is the Ubunet Alliance, which aims to interconnect NRENs so that they're able to interconnect and share resources within the region. Of course, going global, we have what are called GRENs, and an example is GEANT, which is interconnecting the regional research and education networks. Now, there is something fun about networks, data networks owned by NRENs. The first part is that the campus networks at research and education institutions, they form the backbone. So our goal is to make sure that at institutional level, we have good networks. At the same time, the NREN networks form the backbone for other RENs. Similarly, regional RENs networks also form the backbone of global academic networks. There is something interesting about these networks. The architecture is well known, very clear. We normally talk about hub and spoke, but does this well-known architecture translate to high-performing networks if one is to implement the well-known architecture? What we have realized is that this is not always the case. You can't follow the architecture, but you are not guaranteed that your network is going to perform. And therefore, one has to design the network based on what is well-known. You also need to simulate it. And of course, you have to take on board your context as a country. For example, as you're looking at the context, you need to consider your client base. How many clients are you connecting? At what capacities are you connecting them? What technologies do you have to carry your traffic? What type of traffic are you going to expect on your network? How much money do you have to implement your network? Because this has a bearing in terms of what equipment you need to procure for you to have a high-performing network. To that regard, we tried something in Marin, being a national research and education network for Malawi. We became operational recently. This was under funding from Malawi government under a project called Digital Malawi, which is funded by World Bank. Under this, our target was to connect 61 sites. So we became operational, both administratively and technically, just I think a year or two ago. Of course, when we came on the ground, we needed to simulate our network. So we started with a very basic design and wanted to put in a number of other parameters into that basic design. So we tried this basic design, which I'm showing. Basically, we have one piece of equipment which we intended to connect to a number of different POPs across the region, mostly in Zambia, Mozambique, as well as Tanzania. And of course, having another link, linking us to the Malawi Internet Exchange Point. And from there, we needed to connect that to the concentration point where all the clans get connected to. So the journey started. We tried to simulate that basic design. Much as we were trying to simulate that basic design, we had a long-term goal. The goal was to have a network, which I have just put in my slide under that what is visible, where we are trying to now separate so that we bring in more resilience in the long term. But of course, in terms of our simulations, we had to start with the basic design. And if successful on that basic design, we are going to proceed to deal with the detailed design of our network. Now, how did we carry out the design? The first part is we use a simulator called GNS3. It's one of the very good simulators for networks. And we're using Cisco images, C7200 and C3725 images. And this was running on a laptop, single board with 32 gig RAM as well as 2 gigahertz CPU. When we started doing the design, when we did at the core level, and then we started adding some few clients. The target was to make sure that all the 61 sites that were targeted under the project were part of the final simulation process that we are doing. And then for each site, we wanted to make sure that we extended at campus level, because campuses form the backbone for NREN. So we needed to understand what was happening even at a lower level, to appreciate what was going to happen if bandwidth increased by a certain number of times. So we needed to extend, but the design, in terms of the simulation, we started with what I'm trying to show on the screen there, with only 6 clients connected. Now, even with 6 clients, was something quite interesting. I will Bonnet Alliance, which is the Regional Research and Education Network for this part of Africa. So number one, with only 6 clients, we observed that there was average utilization ranging between 73 to 85% CPU utilization. Mind you, we are only 6 clients. Our target is 61. So we are only around 10%, or slightly less than 10%, but utilization is already more than a quarter of the CPU. So the same thing was happening with RAM. So close to 90%, more than 4/5 of the CPU was being used, the RAM was being used with only 6 clients. That's only 10%. And then we got slow responses on the computer. Now, this was also happening on a basic design. Remember, our target was to do this on a very detailed design, which had a number of other elements. But on a basic design with only 6 clients, we already started facing a lot of problems in terms of requirements for CPU, as well as requirements for random access memory for the machine on which this was running. So what we saw was that really this machine had inadequate computing power and something needed to be done. And all the experiments had to be suspended pending access to extra power. Now, my final slide. We need, the need to simulate academic networks still remains for us. We still need to simulate it. We need to deal with all sorts of traffic to appreciate what is going to happen as we increase bandwidth, as we increase the number of clients, as we increase the various aspects of self-provision to our clients. So this problem is just a demonstration that we still, there are a number of other problems that require high performance computing for researchers in Malawi. Now, the coming of this Hpc to Malawi is going to give us opportunities so that we can do a lot of simulations and make better decisions based on data. Thank you. That's my quick.
Thank you very much, CEO, Chief Executive Officer, Malawi Research and Education Network, Solomon Dindi, for that presentation. Obviously, there will be interactions and an open discussion shortly after the 3 more presentations coming forward. May I invite next to present is the Chief Executive Officer, representing the, I would say, private sector in South Africa. It's 1% of that. So you are the 1% maybe in Malawi at the moment. Eugene Masea, Next Gen Labs, virtual reality apps and simulations with computational fluid dynamics, CFDs. So over to you, Eugene. You have not more than 10 minutes. Are you able to unmute yourself, Eugene? And you can speak. You have the floor.
Okay. Yes. Okay. Can you see my screen now?
Yes, and put it in the presentation mode. Yes, so you're audible, but also put the screen in presentation mode.
All right. Thank you. Great. Thank you. So without wasting much time, I will focus on the part of the presentation that has to do with urbanization, how we would utilize a high processing computation facility. So the title of this presentation is the Precision Underground Water Modeling and Simulation for a Complex Urban Area Setting. The team has 2 researchers right now, 2 lead researchers. So that would be me and my colleague Tumbiko Zingwe, who is a hydrologist, remote sensing specialist, and I'm a mathematical scientist with also a 6-year background in remote sensing. So there will be satellites and drones. So forensic hydrology, just a brief overview for some others in the room. There is a branch of environmental forensics involving the use of earth sciences and environmental sciences to assess technical complexities involving flooding, watershed, and hydrographic modifications resulting in increased underground conditions, controlling things such as flow and transport, as well as analysis of groundwater flow and contaminants. So these would be pollutants that can come from industries or wastewater treatment areas, and the determination of risk pathways towards potential receptors and the feasibility assessment of various remedial alternatives. So right there's a model of what forensic hydrology would look like. So this is strongly related to computational fluid dynamics, which is the process of mathematically modeling a physical phenomenon involving fluid flow and solving it numerically using computational prowess. So basically what we're trying to do here is model the movement of underground water as it relates to what's happening on the surface, and mostly we want to focus on this in an urban area setting. I'll talk about that, but bioinformatics, I'm sure most of you here know, is the science of applying geoinformation systems, remote sensing, and related disciplines to understand the Earth's processes and systems. So why? A gateway to critically assess how variations in groundwater processes affect election structures and urban development. Through geophysical interpretation, in-depth information concerning the lithology, geology, and other related hydrogeological substructures will be unleashed, which are vital to safeguarding them from possible industrial pollution. So we know here with the rate at which our cities are growing in Malawi, a lot of the industrial areas are right next to, in close proximity to informal settlements, I would say, the case of Ndirande and Makata industrial area, or Area 25 and Kanengo and Lilongwe and many others. So it is important to know how these two are relating and living with one another. And another point is through the numerical and analytical simulation models, we will be able to have a few insights in the structural hydrodynamics, thereby predicting the flow and extent of possible contamination. This is urban industrial wastes and sewage. Real-time data with embedded sensors are giving us data on recharging and discharging sites will help in underground water management. The scope of our project really would be remote sense data. So this is digital elevation models, which we gather from satellite data and drone data, the GIS hydrological data types, the geophysical data. So this is aeromagnetic data. So we also have equipped on the drone magnetic sensors and gravitational sensors to provide the data on that, on the subsurface conditions, as well as the site data. So this is where we sample the soil, the porosity and conductivity, as well as real-time monitoring, which we will get from the sensors that we will embed in the soil. Basically, this is the project methodology: identification of recharge and discharge areas, both regional and local, then identification of subsurface and surface indicators, as well as recharge and discharge areas, selection of appropriate areas, and then we move on to the validation and the simulation models. This is in more in-depth what that methodology is going to look like. So again, as I covered, delineation and digitization geological maps. In the end, we'll be able to, with the results, to have hydrogeological assessment of groundwater models of target areas. And I won't go into too much detail about this, but these are the hydrogeological numerical simulation models and the hydrogeological structural models on the different substrata underground. We will utilize soil moisture sensors. So here we have the Raspberry Pi, which will help establish surface runoff predictions. What is the need for the HPC? Well, real-time modeling and simulations that will be building off the machine learning models. We'll have water sources and soil data, as well as the groundwater, and we'll also have real-time data from embedded sources. So capabilities to process all this data and run the simulations and the models in real time. The expected project outcomes are integrated maps and models of groundwater discharge and recharge sites, hydrostratigraphic surface and subsurface visualization, numerical models, discharge and recharge simulation models, as well as updated soil lithology and geological maps, as you're seeing in the image there. How is this relevant? As the good professor mentioned, the National Integrated Cyber Infrastructure System. Well, in the Malawi 2063 plan, there is a plan to have secondary cities, and Malawi is one of the few countries in the world which is urbanizing at a very rapid rate of 5% annually. Only 20% of our population is living in the urban area. So with a fast growing trend of urbanization, there is also the need to manage our water resources, both surface water and groundwater, and how the cities are planned is very important to this. And we feel like if we have this model NCIS, that can be one way in having smart management of these secondary cities and how it relates to water resource management. I hope that makes sense. Thank you for your time.
Thank you, Eugene, CEO for Next Gen Labs. And indeed, you are right. The Malawi 2063 and also Malawi Implementation Plan 1 has infrastructure or urbanization as a critical pillar out of the three pillars in there. But also this aligns to what Werner showed in his presentation, which he has shared liberally to everyone. The link is on the WhatsApp in there, where he did give an example where architects, structural engineers are able to design and simulate the so-called climate conscious infrastructure, the hotel that we saw, tested by the winds and all climatic adverse conditions, and it built based on the framework of all how the bending moments would apply. So I think this is in order, and from that industry perspective, you should be able to have an interaction with everyone eventually as we'll be closing for the open discussion. I wanted at this point in time to share regards from the Department of Science and Innovation, South Africa. Karabo Mlambo has just left for another meeting, and she has been exchanged with Lindiwe Gama, again from the African Bilateral senior officials, Department of Science and Innovation, who is here, and she will be giving the closing remarks eventually, but also an eventual closure of the engagement. Thank you, Eugene. Next is the Malawi Welcome Trust, Malawi Liverpool Welcome Trust, on the research program concerning disease transmission modeling using likelihood-based inference algorithms. I think I would like to welcome Wara Pamchedzera, but also Deos Tindwa. You have the floor. Not more than 10 minutes. And then, of course, we'll be having the last presenter. Over to you, Deos and Wala.
Thank you so much. My name is Deos Tindwa. I'm a mathematical epidemiologist. And thanks for the invitation. And we're going to talk about the application of mathematical modeling to infectious disease transmission, and the first will be Mala, who will talk about the TB transmission, and I'm going to talk about pneumococcal transmission. Over to you, Mala.
Okay, as mentioned, so my project here at the Wellcome Trust is on TB screening based on computer-aided chest X-ray diagnosis. And I'm looking at the impact scaling this intervention up in Blantyre would have on incidence, prevalence, and mortality of TB. And we're also looking at the cost effectiveness of doing this. we're using mathematical modeling to explore this impact because of the dynamics of TB infection. It takes maybe several years to understand the intervention's full benefits and costs. So with mathematical modeling, we're able to project its effect over several years, and then it can help, the results can then help with planning purposes. My main objective is to estimate the change after scaling up this intervention in Blantyre over 15 years. So the change would be in instance prevalence and mortality of TB, and then looking at the cost effectiveness of that. To do this, I'm using a transmission model, which is a deterministic compartmental transmission model. And it has 9 health states, which you can see in the diagram to your left. Each of the health states are represented by the squares. The population within the model is split by sex and HIV/ART status, so as to properly capture the TB dynamics of Blantyre. And because we split the population into these categories, this means that the 9 states then turn into 54 states. The model is also being fitted to data from TB prevalence data and case notification data. And to do this, we're using Bayesian methods where we estimate parameters from a prior distribution, and then for each set, we run the model maybe about more than 1,000 times. And then we were able to generate results from this. But then there's obviously a lot of problems that arise, mainly because it's very computationally intensive. To get proper efficient results, I'd have to run the model at least 10,000 times. And within the model, I have about 84 key parameters. So each of these parameters will have to be varied and also estimated. So then using my current little laptop, it would take about 5 days to run. That's if it doesn't crash. And then right now I'm currently using the MLW server, but although it's working, but we do run into problems where the CPU power is quite low. And also, depending on the amount of tasks that have been submitted to the server by other users, the performance of my model can slow down. And currently, there's no formal technical support for the administration, for the server administration.
Thanks, Mala. So I'm going to give a similar scenario where we are trying to understand pneumococcal transmission. And as we may be aware that the Malawi government introduced the pneumococcal vaccines in 2011 among infants at 6, 10, and 14 weeks. And since their introduction over a decade, we've had substantial reduction in both pneumococcal courage and disease among infants, but with suboptimal impact on indirect protection in other groups who are at risk of pneumococcal courage and disease, such as HIV-infected adults. And because of that, there's been a question about the current schedule, which is what we term it as 3+0 at 6, 10, and 14 weeks among infants. And we've been discussing whether to try and model different schedules to try and maximize or enhance indirect protection in other groups. And as we know that vaccines are very expensive, and in order to do this in a modeling setting, it would be much more cost efficient compared to doing clinical trials. So there are a couple of vaccination scenarios that we're trying out, try to change the schedules, for example, into vaccinating at 6, 10 weeks, and then 36 weeks, or vaccinating toddlers at 3 years, or vaccinating school-age children at 5 or 6 years. And because of the indirect protection, which we also call it herd immunity, this becomes a bit complex to do just simple regressions. And that's why we bring in the mathematical model to be able to understand different pneumococcal transmission dynamics, including serotype replacement, social mixing patterns, as we know that pneumococcal is transmitted through droplets from one individual to the next, similar to COVID. So the main objective was really to explore optimal vaccination strategies against invasive pneumococcal disease in HIV-infected adults in Blantyre. So I developed a transmission model for pneumococcus, as you can see from the left side of the diagram, where I split my population into unvaccinated population who are HIV uninfected and HIV infected. And these individuals can be sent to vaccinated populations, which are colored green rectangular boxes. And my model is age structure, is also deterministic and compartmental, because I group individuals in compartments, which are also called states. And in total, as you can count, there are about 16 model states. And because it's age structured, I've got 5 age groups, and in total, I get about 80 model states. So what we actually do is we simulate these models to a steady state. And while they are at a steady state, and then we calculate the likelihood of the observed prevalence pneumococcal carriage relative to the trajectory at the steady state. And once we've got that likelihood, then we can combine that likelihood with the initial belief, which we also call them priors, and to generate the posterior distributions. So how do we actually sample from those posterior distributions for us to be able to estimate the transition parameters? So I've given a simple example of how our MCMC algorithm works, which is the algorithm that we use to be able to sample from the posterior distribution. You can think of it as a mountain. So for example, you have been blindfolded and you have been told to go to the peak of Mulanje Mountain to reach the Sapitwa. And what you see in the first image is the mountain over there. And then I provide an aerial view of that mountain. And I give, for example, steps that for you to be able to reach the mountain, you should walk around randomly. And then most of the time you should walk uphill. And then maybe, for example, every 10 steps that you walk uphill, you should also go downhill, maybe 3 steps. And then if you do that, we can place you at any point in the mountain, and you look at that image, you go randomly wandering all about in order to get to the top of the mountain. Eventually, you end up at the top of the mountain if you follow those steps. So this is how the algorithm works. And you need to take several steps for you to be able to reach at the top of that mountain. So in other words, what I show in my last image there is the data that you observe. So this could be like the prevalence data of pneumococcus. Then combined with your prior belief, you can be able to calculate that posterior. And if you are at the top of the mountain, you can be guaranteed that you are at the top of the mountain by looking at your what we call MCMC chains. So the chains have to look to be stationary. And this is where the Hpc is very important, because for us to be able to take all these steps, it takes a lot of computation power as well as time. So once you get the stationary chains for the MCMC, then you can be able to extract your posterior density, which are the parameter estimates that you need, and which I show them on the right side of the image. And these are for different parameters. So in this example, I show the susceptibility for different age groups who are carrying pneumococcus. And for the current model that I have for pneumococcus, I run more than 100,000 runs. And then that's really important for me to be able to improve the mixing, to have that stationary MCMC chain, but also to reduce the sample autocorrelation, because the moment you keep sampling, you get the autocorrelation as those samples are sampled next to each other in time. And then my target goal is to estimate just 16 key parameters, where I keep the other parameters fixed. And in the current moment, at the moment, I run my models on the iMac, which is 1 terabyte hard drive, 4 GB RAM, and it is a quad core, but it takes about 6 days to do that. So this is really important, I think, timely for us that we have this discussion about the Hpc, because sometimes this is not really efficient, especially when those parameter estimates are really important. And you might actually think of it in the terms of, for example, the pandemic, where the government was really interested to know what is going in terms of the transmission in the population. And our models could not even produce these kind of estimates in real time, because it takes a number of days for the estimates to be guaranteed and to be generated. And that has got a policy impact, because it means if the government is asking for what is happening in the population today, you have to wait for about a week to tell them what is going on, which doesn't really work well with the pandemic, as it's very changing over time. Thank you.
Thank you, Deus, but also Wala. From Wala, we have seen this is actually a critical human capital development area of health. And we have seen imaging, digital imaging limitation, computational limitations in there, system crashing, and this is what needs to be addressed today. With Deus, you have demonstrated the Markov chains, but also Monte Carlo simulations, which are intense and that at a minimum are taking a week. In other words, 52 possibilities in a year to give us results, and then we've lost efficiency 1 out of 6 multiplied by 100. And this is a kind of the gaps that we would like to be addressed. If it were possible, I'd have said today, let Deus, Wala immediately be registered, as users, principal investigators on the CHPC. And I'm sure that during the open discussion, they will ask one more question. I see Verena very happy. Verena says, yes, please welcome and need be users immediately. I think the only question they might want to ask in terms of research program in the health and issues of patient data is regarding confidentiality and terms and conditions allowed to how private the data of this sort can be on CHPC. I think just comment on that when we'll be having open discussion to give relief into the users to know that at least it's the same way that I think they're sitting somewhere. So if you could comment around that. And I think also this applies to every other aspect. I think right now we are inviting the last presenter. We want you to keep your time limited to 10 minutes maximum. If you can do 5, well and good. And that's in the first pillar of the National Development Agenda, agriculture. So we have seen urbanization, we have seen industry, we have seen human capital enabler, and this is now agricultural productivity, commercialization, issues of genomes and gene sequencing and related to aspects of that nature. Lilongwe University of Agriculture and Natural Resources. Are you there? Would you share your screen? I would like to recognize you immediately, and that's Wilson Nandoro. Issues of copy number, detection of copy number variants, and this is within the forum. Yeah, over to you, Dr. Wilson Nandolo.
Hello, thank you for giving me this opportunity. I'm going to be presenting on a computational bottleneck in electric genomics. So I'm going to give an overview of some of the work that is been doing in electric genomics and how it's impacted by computational limitations. As a general background, we made
just to interrupt you, Doc, could you please put it in presentation mode and just check how positioned you are from the microphone? It's as if you are caged, but I think over to you. Just put in the presentation mode, and this is being recorded.
Is it okay now?
Well, proceed in the interest of time. I think you can go through the slides. Yeah, sure.
Okay. Yeah, so there is need for livestock improvement because we need food and other products and services from the livestock. And for us to achieve this improvement, the best way is to select the best animals from the animals that we have. Traditionally, we know the best animals from the population by doing modeling. We basically use mixed models, and the most basic models are such as the best linear and Bayes prediction models. These models require and use a lot of data. The basic mixed models that we could use would be about estimating the genetic effects of animals in order to predict which animals have good genes or have the highest potential for producing the livestock products and services that we need from the livestock. A traditional method of estimating the genetic worth of individuals is based on pedigree information. In other words, the relatedness of the animals that we have. The system of equations that you get by working with this equation involves a lot of.
Your slides are not changing. Are you rolling the slides or you are giving an intro? Just check on that.
I am changing.
Please try to move your slide back and forth. We are not seeing traction.
I have heard that. Anything?
Vergen, are you able to see movement or Brian?
No, the slides are static. I think it is not in presentation mode for us to see. I think that is the problem.
Yeah,
but there it moves now.
Yeah. Okay. Please, at the bottom there's presentation mode. Just click on the presentation and then you do next. Next, we'll be able to have a flow properly. I don't know whether you're using open. You seem to be using open. Then you go to slideshow. Go to slideshow mode. Yeah, slideshow mode. Using your open office. Okay.
Can you see now?
Can you go next? Click on the next slide.
Just a moment. Next.
Yeah, that's it. So no, you were in presentation mode just previously. Yes, use that and go through next with that. And you have limited time now, 5 minutes, please.
Okay, so are you able to see the changes?
Yes, perfect. Proceed in that manner.
Okay. So I was saying that the basic equation, mixed model equations that we use require a lot of matrix calculations, transformations, inversions, and so on. So if you have a lot of records, the computation on a typical computer may take days or even weeks because it is harder to work with some of the matrices that it produces. So we have another way of facilitating the improvement of the livestock, and this is to use livestock genomics, which is in the disciplinary field of biology, focusing on the structure, function, evolution, mapping, and editing of genes. So the major things that we do in livestock genomics basically sequence alignment, detection of genomic variations, genomic prediction of breeding values, functional annotation of genomes, and the genome-wide association studies. I'll quickly talk about this sequence read alignment and assembly. So if you have gone to the lab and you try to work out the sequence of an individual, then the basic methods for sequencing actually produce lots and lots of reads, which needs to be aligned either to each other or to some reference sequence. And the process of doing this alignment is very computational intensive. So on an average computer, like a computer with 8 GB RAM, maybe 2 CPUs with 4 threads, the alignment could take days or even weeks. If you sequence, for example, a certain genome for a certain individual, the sequencing may yield up to 100 GB a gigabase so, data on memory, which needs to be aligned to each other or to the different genome. So doing this requires use of a high performance computing infrastructure because you cannot do it on your everyday laptop. It will take forever to finish. So this is an example of work that was done recently, most of the analysis was done on computing clusters in the US. Multiple sequence alignment is about trying to find similarities and differences between different sequences. Again, the computations that are involved mostly require a lot of memory, processing power, so it cannot be easily done on a PC. The work that I've been doing is mostly in variant scoring, which is detection of single nucleotide polymorphism, or structural variants such as total number variants. The workflow actually also includes sequence alignment, but has further downstream analysis, which requires a lot of modeling, including use of hidden Markov models and other similarly computationally intensive algorithms. So this is an example of some work that came out last year. The analysis was done on a cluster belonging to the USDA hosted at the University of Iowa. In terms of detection of inbreeding or runs of homozygosity, there is the heavy usage of Markov models, especially hidden Markov models, and the Viterb algorithm, and some algorithms use multivariate analysis that also involve a lot of matrix computations, and that requires a lot of computation. So, for example, if you are trying to test significance of some regions of the genome that are considered to be homozygous or the same in an individual, you would want to do computational intensive simulations that may require a lot of computation and takes a lot of time. This work was done using the computer cluster at the Technical University of Vienna in Austria. Otherwise, to do the work on my PC, it would have taken a very long time. Also, recently, we can predict the genetic weight of individuals based on the genomic structure itself instead of relying on the pedigree of the animal. And what that means is that the matrices involved are even bigger. So transforming them or embedding them and so on is computationally very intensive. The process of functional annotation of genomes is basically about multiple sequence alignment. So some of the processes require that you should check the similarities and differences between different sequences. Again, that requires a lot of processing power. Genomic genome-wide association studies are about relating the sequence of different individuals to their state, maybe whether they have a certain level of production or they are affected by a certain disease condition. Again, here you are dealing with a large number of predictors, which means to solve the equations or to get the solutions, you need a lot of computation power. If you do it on an ordinary computer, that will take days, depending on the amount of data and the model that you are using. So, in conclusion, we have an opportunity for accelerated and genetic investment using genomics. Unfortunately, many of the workflows in life genomics are computationally intensive. You could do them on personal computers, but that would take a lot of time. So having high performance computing infrastructure is not a luxury, actually a necessity. Thank you very much for your attention.
Thank you very much, Wilson, being also our last presenter. It's exactly noon or 12 midday, and whatsoever Wilson is doing, his goal, his endeavor, his suffering is to make sure that he can produce or contribute to the production of improved animal breeds, the cattle, goats, and all that, which could be fast growing, but also of highest commercial value, and that builds into the first pillar, pillar number one. He is suffering using Markov models and all those things, I'm sure part of also Monte Carlo and the linear algebra. And these, he has said that sometimes the limitations he has had is that several weeks without solution, no solution at all for days or weeks. And he has received rescue in USA, rescue in Vienna, Austria, to simulate and produce results that he is able to publish. I think, Verena, this is a case in point also, where Wilson can immediately, jumpstart himself and register on the CHPC. Whilst we are waiting for the NICs immediately in the next 4 months, as we're working on the process of shipment and the rest of the things. Without much ado, all the presentations are done. We would like me and Verena together to coordinate 10 minutes. It was supposed to be 20 minutes, but maybe we are all hungry, maybe. Some of us, we don't go for lunch. We should have an open discussion to hear from you. We would like to see your hands raised, and I think we want to hear from the Malawians, and then all of us will be, I think, giving answers and responses. Any hands up? First is the proposal. How many more minutes can we allow to terminate this? We have back here Kalabo Mlambo, who will close the meeting, but how many more minutes should we add? 10 minutes, 15 minutes, or 20 minutes? Any volunteers? Shekana Kasambala, what's your proposal in terms of time allowance, additional time allowance?
All right, thank you for recognizing me first. I propose 20 minutes. It just has to remain 20 minutes. Thank you.
Okay, 20 minutes. Okay, so you have the floor now. If you have any intervention, you have the floor.
All right. At first, when I was raising my hand, I just wanted to say Wilson Nandolo was not audible enough, but of course, after getting into the presentation, I managed to follow the presentations, and I just liked it was so nice.
We are losing you. Maybe you can text and come back later, Shekana. Your network is tripping. So thank you for that. I see Albert was saying, let's keep it to 20 minutes. We take that and you are recognized. Any other hand up? I don't see any other hand up. Please, let's engage. This facility has to come to Malawi. We'll be the users, we'll be the owners, we'll be the technical experts. After the donation, after the deployment, it will simply be collaboration, cooperation, sharing, but will not be babysat anymore. So let's engage, from the data, from the computation, from all the aspects. Comments or questions? Verena, do you have any comment as you could you comment as co-chair?
Yeah. No, while we are waiting for some questions, I want to emphasize and echo what you are saying, tomorrow. I must say, I'm extremely encouraged by the examples that was shown here. I see some direct opportunities for the CHPC to become involved. I noticed those slides where people say they're waiting 6 days on the laptop. I mean, those are the kind of questions that we can probably the most easily address. I mean, of course, there's always the question, the kind of code that you are using, whether it is compatible with our environment and so on. But that is where we start. I mean, you first have a challenge or a problem that you need to solve, and then we explore whether it can be done at the CHPC. So I encourage the people to if you think you are already ready to submit jobs, register straight away for a PI. I already saw 1 or 2 PIs being registered while we were talking. So that is good. We will follow up with you. Those ones come directly to me, so I will be responding to them. But if you are unsure, I mean, I think the main purpose of this session is about awareness of the opportunity. If you're now still a bit confused or you're still wondering whether this is for you, by all means, all the contact details are there in the slide. Make contact with me. We set up maybe a meeting or a discussion. Or if you think, but this message needs to go to a smaller group, say there's a department at the university where you want more people to hear this message, we set up a virtual session and we discuss it further. It's all about starting this engagement. But yeah, I'm extremely encouraged, Chamora. This is I think a good start. And I think I mentioned to you, and I want to say to the people online, I see it as success if there are key researchers coming forward. It doesn't have to be 50 researchers. Even if we have 2 or 3 or 4, say, research groups starting to use, say, the CHPC productively, and then also transitioning into the use of the Malawi systems, this is already a great success, because what we need is people that will champion these opportunities going forward. It doesn't help me or Chamora trying to tell people this is useful. It is much better if people try it out themselves and then talk out of experience. They can talk to their colleagues. So I see it as a very encouraging start, and the invite is out there for people that want to discuss it further. So maybe I will stop there for the moment, Chamora.
Thank you, Co-Chair Wagner, for that. I see Hastings Musopole, you have your hand up. Ivan, you make one 30 seconds comment. Dr. Enea, Director of Higher Education, also a comment as we are getting a few more hands. We'll stop at 12:20 with closing remarks by Kalabo Mlambo, the Department of Science Innovation, South Africa. I saw another hand up from Mark Herion, so we'll start with Hastings. Hastings, over to you.
Thank you very much. I do appreciate for this initiative. However, I just want to find out from you, Professor Mikeka, while I do appreciate that we'll be able to access the facility from South Africa, but I would like to find out when should we expect the facility in Malawi? Apologies in case maybe I missed in your presentation, but I just thought it's important for me to know when do we expect this facility here in Malawi. Thank you very much.
Thank you, Hastings Musopole. A quick answer to that one is that the facility, the equipment is being shipped from South Africa to Malawi, addressed to the Secretary for Education, Ministry of Education. And a site preliminary selection by the Hpc ecosystem has been done on the technical merit of all possible institutions, and the 2 have been pre-selected. A final assessment of the same will happen in the next 2 weeks, where judgment will be made. And this concerns, as I said, the universities, but also research and education network based on their capacities. And once that site is known, the equipment will be deployed there. And by June 2022, this is April, May, June, in the next 3 months, when we shall be hosting as chair of the SADC Joint Ministers of Education, Training, Science, Technology, and Innovation, 14th to 17th June, we would like to have our ministers of education from the 16 member states on 16th or 17th visit the deployed HPC at the site, which have been known then. That's why everyone is working with high energies, with a lot of computational effort to make sure that this happens by June. That's to answer you, Hastings Musopole. I see a hand mark from Mark Henrion. Mark Henrion, over to you. And meanwhile, I think Verena will be saying that for South Africa, how much time can be given? Is it 6 months? And how much capacity in terms of storage? I saw from Wilson that when he does the coding.
So you accidentally muted yourself, Chamora. Maybe just repeat.
Oh, okay. Sorry. Was I unmuted when I was responding to Hastings?
No.
Oh, okay. So Hastings. So what I'm saying that to answer you in brief, it's to mention that we are looking at June 2022 to have the site already deployed at the site which the preliminary selection has already pre-selected 2 sites in Malawi, and then we'll finalize in the next 2-3 weeks. The equipment is already being shipped from South Africa, addressed to the Secretary for Education, Ministry of Education, Malawi, and it will be relocated to the site which will be selected finally after massive technical evaluations, participation of all Malawian higher education institutions, but also a National Research and Education Network. And we would like to invite ministers, the joint ministers of education, training, science, technology, and innovation in June between 16th and 17th to visit this site, see users using on them, and giving testimonies or updates regarding how it has, crashed space and time in terms of computational aspects and the results that would have been seen, including publications which would already be registered. But I say by extension to that, Verena can also give us an indication when we register today, like two have already registered on CHPC already from this meeting now. How much time do they have? Is it 6 months, 3 months? And in terms of storage capacity, how much is available? I saw Wilson in his presentation when he talked of the copying, calling, location sequencing. There's a need for larger storage, over 100 gigabytes when he does a preliminary, sequence results. How much storage is available for a single user as a PI or so in terms of all that? I think that Verena will comment. Yeah.
Yeah, maybe just a quick comment on this. So if you register a research program, you get an allocation of, by default, of 100,000 core hours that is valid for 6 months. And we use then your usage pattern. So when we get to the end of 6 months, we expect your feedback from what you did. And then we see if you actually need more hours, you can show that you can use more hours. For the next allocation, we might increase that hours. So 100,000 is just default. And then when it comes to storage, so what we provide to you is the Scratch Luster fast parallel file system storage. We've got a total of about 4 petabytes. So it's 4,000 terabytes, of which half of it is about in use at any given time. So there is about 2,000 terabytes of data on that Scratch. So if you need to bring a few terabytes of data, there will be no problem for you to upload it there. But the main point to remember is this is only temporary. It is only data. It can be kept there for a maximum of 90 days, 90, then it is automatically deleted. So it is really just for while you are doing your simulations. You cannot store it there for a very long time. But there should be more than enough storage. You should not have to worry about putting your data on that storage and having it available to be used. So I hope that answers the question.
Yeah, thank you very much, Verena. I see a question from Mark Henryon. You texted, but I think you can speak to it. Mark, you have the floor, and then I'll invite Ivan, but also Levis.
Yes, thank you. Very, very, very exciting presentations, and I'm really excited to see this opportunity in terms of infrastructure. I think my questions was largely similar to Hastings, so it has already been answered, and there's been more details in the chat. Maybe just one question. So if we now register on the CHPC system, would those accounts transfer over to the Malawi system, or would that be a new registration? Thank you.
I can maybe just say that it's unlikely that it will just be transferred. And I think the setup of the system is to be decided by Malawi, but I would assume that you would have your own registration and accounts creation for that new system that will be implemented. So I think that is just the short answer is probably no, that will not happen.
Sure, many thanks.
Thank you. Then Ivan and then Levis.
Well, just a comment to conclude. I mean, I would say that, well, first of all, thanks again for the invitation and a very interesting initiative. As I was saying from the ICTP, I mean, this has been an effort that we have been doing since many, many years, so to try to support and foster HPC utilization, especially in large-scale application in science. Therefore, we look at this with a very, very nice, with interest and fruitful collaboration. So let's keep in touch. And if you need more information or you see some opportunity with the master program, please feel free to contact me offline. Thank you very much again.
Thank you, Ivan. Ciao. Then Dr. Nea, Director of Higher Education Institutions in Malawi, Minister of Education. You have the floor.
Thank you, Chair. I had 2 questions, and one question has already.
We have lost you. Please switch on the mic, DHE, and then you have the floor. We seem to have lost.
Yes,
okay,
yes.
Yeah, welcome back. Welcome back. Yeah.
Yes, my apologies. You lost me because I had a trip in the network. So I was saying I have 2 questions. Henryon has already asked the one question, and I'm happy with the response so far. My next question was, is it the case that at CHPC you have a 24/7 dedicated technical support? Because I would imagine that if I'm submitting my problem in the manner described in the presentation and on the website, I might still find some issues, even though I've tried to code in a manner and submit the job in a manner that we have described. Is it possible that I can get support 24/7?
Maybe
so that's a question, Vekana.
Yeah, so officially we do not have a 24-hour support. I mean, there are not people, say, on duty and checking incoming queries right through the night. So I just have to put this out. But of course, in normal working hours, which is the same as in Malawi, we have people always on standby and available. But I must say, if your query comes in at, say, outside of normal working areas, there's a good chance that we will pick it up and attend to it. But officially, we do not guarantee 24 hours. So if you now submit a query at 3 o'clock in the morning, the chance is good that you will get your response maybe, say, around 8 o'clock in the morning. So I hope that answers the question.
Thank you very much, Vekana, and also Director Higher Education, Dr. Levi Senea, who is also a mathematician and a modeler. I appreciate that. I'm sure that he would also be interested to do that. Finally, I see that there are no more hands up. I would like to invite Kalabo Mlambo in the next 4 minutes to conclude and close this virtual engagement. Kalabo Mlambo, I saw one message from Brian Johnston, who is ready to fly into Malawi with their team, the CHPC or the Hpc ecosystem, in terms of the physical inspection of the 2 finalist sites which have been pre-selected in Malawi. That will be happening in April with the SADC Secretariat and other entourage. Over to you, Kalabo Mlambo. Where are you, Kalabo?
I am here. Thank you so much, colleagues. These are very insightful information around, computing and stuff like that. I myself am a social scientist coming from an international relations background. So I've learned quite a lot, about the systems and actually how it can help and make easier the work and sharing of information, and obviously collaboration beyond across borders. And, most importantly, we do hope that, outside of this, there could be, bilateral collaboration as well among researchers and universities in South Africa and Malawi. And I love that, Prof. Mikeka, you were indeed able to share the draft plan of action, which we will be soon signing. And I do hope that, when Dr. Werner and his team come down to Malawi, we could also possibly, host a joint committee meeting where we can, finalize the plan of action and, future implementation of other activities. Colleagues, it was so nice to actually also see people coming in great numbers to support, learn, and definitely engage with this platform here. Thank you so much, colleagues, for that. And with those very short words, all I'm saying is I'm looking forward to, the collaboration and the greater heights of our STI bilateral. And Dr. Werner, thank you so much for also hosting this. I also do know, with our other African partners like Lesotho just recently, work has also been going down over there. Thank you so much, Dr. Werner. And with those short few closing words, I would like to say thank you all. And from the Department of Science and Technology, Science and Innovation, we are looking forward to the success of this project. And yeah, thank you so much.
Thank you.
You are muted, Prof. Prof.
Okay, I was saying, Vekana, you can now say goodbye. If the tech people can do a picture, let that picture be done. But otherwise, thank you very much to everyone. Vekana.
Yes, thank you very much from my side. As I said, I'm very encouraged by the interest and the energy that came across from this meeting today and with the people online. So my invite is open. Please don't hesitate to engage. If you know it will work for you, by all means, go ahead and register. Otherwise, come and talk, that we can see how we can assist. I'm looking forward to further engagement. And tomorrow, I've never been to Malawi, so I'm looking forward very much to that first visit and maybe using that opportunity to see face-to-face some of the researchers that's online today as well. So thank you very much.
Okay, perfect. Goodbye and enjoy your lunch. Bon après-midi. Bye-bye.
Bye-bye.